where I was. Let's turn it over to Shannon.
All right. Well, thank you everybody for joining me on the last session of B-Sides today. Has everybody been having a good time so far? Yeah? All right. Great. So I have a presentation that I normally do in 2 parts that normally takes almost 3 hours to go through, and I'm going to cram it into 50 minutes, which means I'm going to do a lot of demos, a lot of talking, a little bit of talk about remediation, and at the end of it, I'll give you my email address with a specially crafted subject line, and I'll automatically email you the deck, okay? So you don't have to worry too much about getting notes. If you do have questions, you might be able to sneak one in, but otherwise try and grab me afterwards, which also is going to be a short window because I have to catch a flight really fast. So, I want to walk you through a series of attacks that we can do. And I'm really glad that I heard earlier about the idea of needing to get back to basics, because what I'm doing in this series is all basic stuff. Right? I'm trying to show some exploits and attacks that we can do that take advantage of some bad practices, poor configurations, and just see where we can go from there. So when we go through this list, I am using some really lazy, really loud kinds of activities. These aren't necessarily the kinds of attacks that you might see from, experienced and seasoned pen testers, but these are also the kinds of things that pretty much anybody can do. And some of these things that we're going to go through, you should be able to remember how to do them right after we go through them. So there are obviously better tools that you can use, but we're not necessarily going to use any of the suites of things. So just to kind of set the stage, we're going to start at the beginning where we have to get into an environment. And then we're going to grab a foothold and do some reconnaissance, find our way around the environment, and then actually get to the point where we steal some stuff. Right? So the first thing we're going to do, this also relates to the 3 machines that ultimately we're going to be working on. First is the workstation that we're going to compromise, find our way around that box, steal some stuff off of it, use that to jump into a member server in an environment, and then own that as well, and jump from there over to the domain controller where we ultimately steal all the things. Does that sound good? Want to check it out? Okay. So, first thing, I'm Shannon Fritz. I'm a solutions architect at Concurrency. And at Concurrency, my job is basically to work with customers on improving the way that they do things. So I help people figure out better ways to use tools that they already have, as well as work their way through some problems that they have. So one of the problems I have are my notes are missing. So we'll grab this. I said I had no time. Okay, we'll use these notes. Great. So let's go ahead and get started. We're going to kind of set the environment where we are at a company where somebody just lost their laptop. That could be somebody actually got mugged. Maybe they left it in a subway or something. But maybe somebody went to the bar and they went to the bathroom and come back and their laptop's gone, right? Just like I did just before the thing. Nobody stole my laptop, so thanks for that. The question though is, what can happen with that laptop? Sometimes people are thinking they're just going to format the machine and then you're going to give it to somebody, right? Well, that's a loss of equipment, but what else could happen if somebody had some more nefarious things in mind? So let's go ahead and jump over to the environment here where maybe this is the laptop. So assuming that I'm the person that stole the machine and I booted it up, I can tell that this is David's laptop, right? And if I wanted to, I could click over here, another user, and I can see the name of the domain that this is on. So I get an idea of, what organization this belongs to. If I want to get into this machine and actually take some stuff off of it, if I knew his username and password, that'd be really handy, but I don't, right? I don't have his finger, so I can't do fingerprints. I don't know his PIN, and I don't know any of those other kinds of gestures to get into the machine. So the easiest thing that we can do is really just reboot the computer. And of course, we boot this thing off of a CD like the Windows Setup CD, right? So we're not using a hacking tool or a suite or anything. We're literally just getting the Windows Setup disk, booting off of that. And then when we're running the Windows Setup, it loads Windows PE. Windows PE is the Windows pre-execution environment, which Windows uses to run Windows Setup. And Windows PE includes, if you hit Shift F10, a command prompt, right? So in this command prompt, we can start looking around and interacting with the system. And if we want to do things with a GUI, of course, we can use something like Notepad. And Notepad, if we go into File and choose Open, we can use this as a way of browsing around the file system. And we can see that I have on here the C drive, and I have a USB drive, and I can use this to exfiltrate some data. That's what I'm going to end up using it for. But because I have this, I can actually go ahead and browse around and see on the C drive under the users directory, here's David's profile. Under there, I can see his documents. And then if I change the type down here to everything, I can copy this file, go over here to the USB drive, and I can paste it. Right? And then, oh wow, I just stole some stuff. Right? That's all well and good, but it's pretty cumbersome. We're not going to get very far doing this onesie-twosie file copy stuff. So, of course, if I had other stuff on this USB drive, like some tools I could run, I might be able to do something with that. But we actually want to get into this user's machine. So we can do something else where we go to the C drive, go to the Windows, go to System 32, and there's a file here called sethc.exe, and we're going to copy the cmd.exe right over top of it. Say yes. And then we're going to close this, say yes, and it will reboot the computer. This time we're not going to boot off the CD, we're just going to let Windows load normally. Does anyone know what sethc is? No? Sticky keys, yeah. Sticky keys is an accessibility option, right? So if I need to type a lot of things and I don't have all the fingers that I need, sticky keys can be really helpful. Well, I can use that just by hitting Shift. So if you've got your Windows machines open, you can hit Shift 5 times, and you just hit Shift 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, and sticky keys runs. And if we look at this machine, oops, I want who am I? So now we can see that sticky keys does in fact run. sethc.exe is the file that ran, but I can also see that I'm running in the context of system. So on the lock screen of this machine, without any kind of account or access to it, I can actually now invoke actions as the system, which is going to be super helpful, right? Because now I can start getting into the computer. Well, the question is, what would have stopped that, right? We'll get to that in a second. I want to get into this computer first. So the first thing that we'll do is run comp mgmt.msc. And this will run the computer management console, again, in context of the system. If we go over here to local users and groups, we can see, hey, this computer has an account on here called local admin. Now, I could right-click on this and reset their password and then log in with that account. But I want to save that for later. We're going to leave this account for now. So instead, we'll right-click, we'll create a new user, we'll give them a clever name, we'll give them an even cleverer password, tab. Make sure that password doesn't expire, click on create. Then we're going to go to the properties of that user, and we'll make them a member of administrators. Say okay, okay. And we'll close this, and then we'll go ahead and click on Other User. We'll log into the local machine as my Haxor account, and then we're going to log in with that password I just set, and now I can get into the computer. That's pretty handy, right? And that's an easy one. That one we should be able to remember without a whole lot of effort. You literally just replace sticky keys with command, reboot the machine, and then you're in. So let's jump over to the deck here quick and then ask that question, what would have stopped that? Any ideas? Event logs? Event logs would show that that happened, sure, but what would have prevented me from changing that file? Loading off the CD? Well, not exactly. That would have prevented me from using that particular method. But if I wanted to stop users from changing those files outside of the system, I basically want to encrypt the file system. Right? So if I want to encrypt the C drive, that would mean that unless I have the decryption keys, I can't interact with the file system, right? Well, lucky for us, we have ways of doing that inside of Windows. It has BitLocker built into it. If you have Windows Pro or Enterprise Edition, then BitLocker is included, and you just have to turn it on. And a lot of times that does not happen because people don't know it exists, or they think they need a certain special SKU or something for it. But BitLocker is just part of Windows. Any user should be able to go to the C drive, right-click, and enable BitLocker. If you want to control it, there are group policies you can put in place that'll tell you what to do when you enable the encryption. So you can say, force the recovery keys to be stored in an Active Directory, for example. So if a user were to encrypt something, you could actually decrypt it as an owner of the hardware. But if you want to programmatically encrypt it, make it happen you need an agent to do that, and that's what MBAM is. MBAM is the Microsoft BitLocker Administration and Monitoring. It's part of MDOP, so if you have software assurance, it's all part of that too. It actually also includes self-service portals and help desk portals, so people can go there and get their recovery keys. You can show auditing of those recovery keys being distributed, and you can also show compliance. So if you need to show that your machines in the environment are being encrypted, MBAM can give you those reports too. There's also a new option in Windows 10 called Azure AD Join. Has anyone heard of that? Azure AD Join? Yeah, so if you've got Azure Active Directory, the new thing for Windows 10 is you can still do traditional domain join against Active Directory, but you can also do Azure AD Join, which is a whole different thing. Azure AD and Windows AD are synchronized with each other, so whether you join one or the other, your corporate accounts can still log into those accounts. But if you're an Azure AD Join machine that the hardware is instant go capable, which is the marketing term for connected standby, if the hardware can do that, it will automatically be encrypted with BitLocker. So there's a lot of ways that you can turn BitLocker on and off. Some other things that we can do with Windows 10 is called Windows Defender ATP. Has anyone heard of that? You've heard of Defender, right? But Defender ATP? Yeah? So Defender ATP is new for Windows 10 Enterprise, and it requires the E5 SKU. And what this does is it gives you visibility to activities happening on the workstation. So it lets you see things inside of memory. It shows processes that fork other processes. It sees where files come from. It can even integrate into other services. So if you use like Office 365, for example, we can see that a file that was opened from an email attachment, we can actually go back into O365 and see the email message that it came from and then reach into other people's mailboxes and take those attachments out. So it's got quite a bit of access into the environment depending on the services you're using. So I want you to see that quick. So if we come back over here, this is the console for Defender ATP. It's under the Defender Security Center. And in here we can see things like alerts. So this dashboard shows a heads up of various alerts. And in my environment I do various things, so various alerts will appear. But we can see things like this abnormal file information mismatch, so we can click on that and we can see that, hey, this file doesn't look like what it's supposed to be. So here's a message saying, look, sticky keys is what I expected this to be, but it actually is not, right? And we can see what it did. So here, the sticky keys came down and ran Who Am I, and it also ran the MMC, which is what we did earlier, right? Started it up, I ran Who Am I to make sure I was running the system, and then I ran the computer console. So we can see those processes that are happening on the client, and then we can also start taking some actions on these things. So we can see, well, this was running on this Win 10 user machine, and on this machine we can see, well, what other alerts on there? Well, I've done this demo before, so we'll see some other things that I've done in the past, but we can see that there's something bad going on here. And we can use this to dig further into where it came from, what it touched, who it involves, but we can also see like who else is logged onto this machine. So we can see here that not only is David using this computer, but so is this Haxor account that I just created. And all this stuff gets bubbled up into the Azure hosted Defender ATP service. Now, if I decided that I don't like what I'm seeing here and I want to kill this machine, under Actions, I can come in here and click on Isolate Machine. There's also the option for an investigation package, which basically lets me remotely instruct the machine to give me a memory dump and other file collections of what's going on this computer so I can look at it. If I want to get more information, if maybe what's in the dashboard is not adequate. But if I do Isolate Machine, it basically instructs the client to shields up the firewall. So no communications in or out of the machine except for the Defender ATP service. So that way if someone's on the box and has a reverse shell and I say, nope, can't talk to anything anymore, that machine effectively goes offline. And now I can call the user up and say, hey, something went bad, let's talk about this, and then figure out what else I need to do. So the really nice thing about this service is that you actually get visibility to actions very near real time. You get your alerts, but you can also then stop it remotely. You don't have to go find the port that it's on and like pull it off the switch or drop it off the network. You can do this through an internet-connected machine. So that's a real quick overview of Defender ATP. Let's jump back over here and show you what's next. Okay, so now that we're on this machine, we want to figure out what we can do with it, right? So we've got an account on the computer. What's on here? If we jump back over here to my workstation, now we're logged into this computer as the Hacksaw account, and some of the stuff that you typically do when you get into the machine is much like what I did when we booted off of the disk. So we'll go into users, and here's David's account. When we click on it in this context, now it says I don't have permissions to access David's files, but I'm a local admin, so I can grant myself permissions to those files. So I go ahead and do that. Now I can still go into David's documents. I can see all the stuff that he had in here. I can copy these files, of course, and then if I wanted to actually take them, we'll go ahead and go over to the USB drive that I've cleverly attached to this machine, and we'll paste it in there. And look, we just stole his documents. We can also see some other stuff. Like in this case, David happens to use OneDrive for Business, and in OneDrive for Business is an Office 365 component, but he's got his content synchronized locally, which we can then browse through here, and then there's all his docs, and passwords is always my favorite one to look at because, look, I can see context of passwords that he's used, and this is not a terribly uncommon practice for people because they manage and deal with a lot of passwords, so they have them somewhere, and now we can read them. And now as an attacker, I can use these against them because now I can just log into these services most of the time. So if we're not using things like multi-factor authentication or we're using password manager, this is a pretty big risk of somebody's machine if they're not encrypted. But I'm not looking at those services just now. Instead, I just want to take all of this stuff. So we'll come over here, we'll take his pictures and his taxes, and we'll paste these over here. So now I just stole all his stuff. One of the other fun things to grab off of a machine is app data, local, Microsoft, Outlook. And in here is his mail. So we'll go and copy paste that, and now I just stole his inbox. At least I stole what's been cached, which by default is a year. And if I go and open that up, I can now read David's mail for the last year or so. And what kind of stuff can I find in his mail? Like a lot, right? I can start making associations with understanding who he works with, who his friends are, who his enemies are, what his projects are. If he's been onboarded recently, I can probably even figure out how do you get on the VPN or how do you get on the Wi-Fi. There's probably credentials and things to get into the organization in this person's inbox. So it's a treasure trove of things to dig through. But we're going to deal with that later, right? So once we've got all of that, the question then comes back to what can we do about that? I just stole a bunch of stuff off of his files. Is there something that I can do to mitigate that risk? Yeah. There's a couple of things we could do. One is indirectly we can solve this with some encryption, right? If I can't get into the machine in the first place, then I can't steal those files. Of course, if we're dealing with access via reverse shell, right? Somebody got an attachment and he ran a malicious macro or something, and now I'm actually acting as the attacker remotely in the context of David. Well, David has access to all of this content, so I can still get the files. So BitLocker doesn't totally help in that case. But if we wanted to actually encrypt the files themselves, we can use something like Azure RMS. And Azure RMS allows us to encrypt the files and associated with the user's account. So David would have access to decrypt and read the files. But if I'm on a reverse shell and I copy the files down, I'm no longer running in the context of David and I can't read the content of the file. So if I took it offline, like in this case, I am not running as David, I'm running as Hacksaw, and Hacksaw does not have the ability to decrypt those files. We can also use Azure RMS for encrypting email messages. So while I might have taken his mailbox, I wouldn't be able to read necessarily the protected messages in the mailbox. So you might decide that messages from a certain department or containing certain keywords or some other type of syntax should be automatically protected with RMS, and we can do that automatically. Windows 10 also includes something called WIP, which is Windows Information Protection, and it uses Azure RMS under the covers. It allows you to take the complexities out of RMS as a developer. So if you look back in the history of RMS, it hasn't been well adopted because setting up the infrastructure for an organization is a big pain in the butt. And coordinating the use of RMS between organizations is an even worse pain in the butt because you have to authenticate across to each other to be able to read the documents, and it's a big pain in the butt. Azure RMS takes that away because you're all using Azure AD and your organizations are effectively federated and you're all big one happy family in the cloud because you can authenticate and share with each other. What WIP does is it takes the requirement of putting the SDK in your application to leverage the RMS functionality, and it actually does it in the operating system. So now we can declare enterprise applications, and Windows will do the encryption of the files that they interact with for us. So now I can say, Notepad is an enterprise application. You create this text file, and it's RMS protected. But the user still just interacts with it like a regular text file. And as soon as they close the application, that text file on disk, if I were to take the text file away, it would just be an encrypted file, and I wouldn't be able to do anything with it. But David wouldn't really know any different. So that's WIP. All right, so now we are done with the client, right? We've basically broken into the machine, we stole a bunch of files off of it, and now we want to go to the next thing. So how do we find our way to the CorpNet? In this case, I'm actually going to show a different machine real quick. So the demos that I'm doing are on VMs because I'd like to rewind on a snapshot, but it's really hard to put a wireless network adapter in a virtual machine. So I have a physical machine that is set up very much the same. If we open up a command prompt here, I'm actually running this machine. It's joined to the same domain, but I'm logged in as a local account on here that I created the same way we did earlier. On this computer, other domain users have used this machine to connect to other wireless networks. So when they do that, the computer stores the pre-shared key in the registry so it can be used to automatically connect to the wireless network later, which is super handy for me because I'm a local admin on the machine, and when I go to the wireless networks, I can click on network settings, and I can see all of the other networks under manage known networks that this person or this computer has connected to. So I can see things like, my boss's phone, I can see our corporate network, I can see home networks and all that stuff. And since I have this machine, all of that data is stored on the computer. So what we can do, let's go to users, Hexor, desktop, and let's do NetSH, WLAN, export, profile, key, clear. I got to spell NetSH right. And what this does is it goes through that list of all the profiles that have already been saved, and it creates these XML files on the desktop or wherever. And because I told it to make the key clear, I can see not only the SSID of the network that I'm connecting to, but I can see it's a WPA2, and here's the plain text password. So if you want to connect to my boss's phone, here's his pre-shared key. Happens to be all ones and zeros, which is a great practice. It's actually not his password. I made that up. But any wireless network that this machine is connected to, I can do that. This administratively actually has a purpose. The idea here is that I could pre-configure my wireless connections and then distribute these files and not have to tell users how to do that difficult process of connecting to wireless networks. But there are much better ways to do that. What I can do now is take this information and I can go to this person's corporation and I can now connect to their network because I have the pre-shared key information, right? So if we were to pretend that we did that, right, we could go look up their company name. Maybe I'm targeting this company and that's why I took the machine, or I just look them up online. Sometimes the SSIDs, you can go to like wiggle.net and you can search for the SSID and figure out where it is on a map. But now I can go and connect to the network. So let's take a second quick here and go back and say, what can we do to stop that, right? How do you stop stealing that off of the machine? Well, first, local admins can do this, right? So if you're a local admin, then there's nothing to stop you doing it. So the first thing is stop giving people local admin rights. So in the case of a remote shell, right, if I'm remoted into this guy's machine through that malware hijack, for example, if he's a local admin, I can slurp off of his machine all of the wireless networks, and I can go in and attach my own device. So if he's not a local admin, this isn't the way that I could pull that off. I'm also told that this will also export the certificates of a wireless network if you're using certificate-based Wi-Fi. I haven't verified that, but I understand that's the way it works. And if you're using certificate-based Wi-Fi, which is a good idea, just make sure that the client certificate doesn't have the private key marked as exportable. Sometimes the template that's put in the certificate authority has that certificate is exportable checkbox set. In this case, that's not a great idea. Yeah. Sorry? with the private key?
Yeah, even if it's at like non-exportable, because
Yeah.
that key has to be stored somewhere.
Yeah.
It just makes it not easy to like go really right click export.
Yeah. So you get it? All right, you're going to have to show me that. I want to know that trick. And the other option then is when you're connecting, if you use Radius, then you have to have the user's credentials to connect via Radius, as long as that information is not stored. That makes it a little bit more cumbersome on the user now because they have to enter the creds. Or if they're doing Windows-based authentication, they can then do SSO. Now in this context, I don't have David's credentials on this machine. I'm just logged in as a local account. So I still can't log in if I'm using Radius in that case. And if you do go down this path to do the management of the wireless networks, using group policy is your friend. I mean, you can do certificate enrollment automatically, certificate renewment automatically. You can configure the wireless network settings automatically. You can also do the same thing with mobile device management. So if you're doing this like with Intune, for example, you can manage that through enrollment of the device. And Windows 10 can also be managed as MDM now. So if you want to use, Intune or you want to use AirWatch or something, arguably you can use Intune for managing and configuring those settings as well. Okay, so if that is the end of the client side, we've basically gone through the point where we got into the environment and we broke into the machine, and now we're ready to start moving around, right? We've got the wireless network information, and we know where this network is, and we've gone to connect to it. So let's look around a little bit and figure out what we can do. We are going to go over to this member server. So to do that, what we're going to do is jump back to our workstation, and we can close these out. Now, one of the tools that I've ended up using a lot, I used to do a lot of deployments of direct access, and with direct access I had to talk to Active Directory a lot, and there is a tool to talk to Active Directory called NLTest. I don't know if you've used that before, but let's make this a little bit bigger so you can see it. Change that here. Okay. So NLTest allows you to basically do queries against Active Directory and interrogate some properties of the DCs. So if we do NLTest/DC list, what this should do is connect to Active Directory and list out the domain controllers. But I'm getting an error message here that says that I don't have access to do a directory services bind, but then it tells me the name of the domain controller. So that's super handy. It also happens to tell me down below that it is the primary domain controller. So that's also really useful because ultimately that's my goal, right? My goal is to get to the domain controllers, and why not go for the PDC? So the one caveat is I would like to know a little bit more about the environment, and the NLTest usually tells me more than just a single domain controller. The problem is I can't do a query against the directory services because I don't have credentials, because I'm a local account on this machine. But this machine is joined to the domain. So the domain allows a authenticated user to do queries against it, and the computer is an authenticated user. So if I can use the computer, I could do these queries. And we did that before by using the sticky keys, right? So 1, 2, 3, 4, 5. And if I do who am I, the downside here is I'm actually still running as Haxor instead of system. So I want to use another tool. Now, for sake of time, I already downloaded some of these tools, but the tool that I'm going to use is our good old friend psexec. We'll go ahead and copy our psexec tool right over here to our C drive, and I'm going to make a new folder over here just called tools. We're going to paste that, and then I'm going to change over to the tools directory, and then here's psexec. So if I use psexec, I want to do a system, interactive, do not wait, cmd.exe, and then accept the EULA, right? We've got to make sure we do that. And now I can say who am I? And of course I do get the system back. So now I can use tools just to invoke a system process because, again, I'm a local administrator, so I'm allowed to do these sorts of things. Let's make this a little bigger so you can see this as well. Go to properties and change that here. And we'll make this scroll back a little bit bigger. Okay. Now, if I go back to our tools directory, and I can do nltest/dc list, which is what I'd done last time, now I can see a little bit more information, right? So now I can see that Not only is DC3 there, but I have DC4, and I also have a domain controller and a whole other site. So what that gives me is the some lay of the land, right? If I want to go after other things, I know what other sites there might be. I can start looking around for different subnets and routes to things. But it just kind of gives me a little bit more information. So what's next? What else can we find? Well, now that I'm able to do queries against Active Directory, I can do things like tell me who's in the directory, right? So there's net user in the domain. And this dumps out all the users in Active Directory, so I can get a list of all of the accounts. I can see naming conventions. I can usually do some guessing on other services and products that they're using because naming conventions are inherent to humans. We can also do net group in the domain. And this will actually dump out a list of all of the groups in AD, which, again, gives me more insight to things like what products they're using, right? Here's some RDS, and there's SQL, Exchange. And I can start using that to look up what kinds of attacks might I do, right? If I wanted to get into SQL, I can at least know what versions or what servers they have. But even a better one to do here is if I do net group domain admins in the domain, DOMAIN. Now I can see that these are the users that are domain admins in this environment. Now, what can you infer from these names? Right? It starts with A. They're probably the admin accounts and they're people. The other ones that start with S are probably what? Service accounts, yeah. And what do we know about service accounts? They never change. Passwords never change because, that's a pain in the butt. So we don't want to deal with changing passwords. But it turns out we have service accounts that are domain admins. So why not go after those, right? We'll have all the time in the world to try and figure out their passwords. And they have all the access that we need. So if we start looking at these, we might say, well, I want to go after SQL Server, or maybe I want to go after this one called App Service, or I want to go after some other user that's in here. But I am adding that to the list, right? So I know the domain, I know the domain admins, and I know some about the products that they have installed. But I need to know where to go. I need to figure out where I can find these accounts. So one of the things that we can do is go back to comp mgmt.msc. And again, I'm running in context of the system, so this is going to be able to talk to Active Directory. We'll go under users and groups, but this time we'll go to groups. Pick any group. Administrators is fun, so we'll just use that. And then we're going to go to an advanced search. We're going to change the object types to just be computers. And then we're going to go ahead and hit Find Now. And when we make this window a little bit bigger, basically what we were able to do here is just dump out a list of all of the computers that are in Active Directory. And if my fingers would work with me here, I'd show you that. So here, all right, so we've got some computers, and now we can start getting names of machines, a further understanding of what other stuff's installed, because we typically install our products on servers that are named after what they run, so we can start doing some inferences here to understand where to go. Well, lucky for us, we have this machine here called App Server, and we know we have a service account called App Service, so if we're going to be a betting man, I'd say that they're probably related to each other. So if I wanted to get to App Server, I need to know how to get to the machine, right? Now, if I was an administrator in the environment, what do I need to get onto that machine? Like, how do I administer that machine if I'm an administrator in the organization? Probably remote desktop, right? I'd RDP to the machine. So chances are I can RDP to this machine, but to get to RDP, I need credentials, right? So let's actually just pause for a quick second and go and find out what we can do to stop what we've done so far, which is mostly our recon, right? So let's go over here to our deck and say, what can we do to stop some of this? Okay, so actually, I'm trying to remember if I have this part next. Yeah. Let's do one more thing, and then we'll come back to the deck. I want to show you a little bit more, and we'll do that again. Okay, so if I want to get this, I want to RDP to this machine, I need credentials, and I don't have any credentials for the domain. I know I want App Server, or App Service, but what I do have is this local admin account on this machine, right? Now, because this is an account that lives on this machine, that means its credential lives on this machine too. And I'm also a local admin, so I can go and read that. Now I want to use another tool to do that, which is a tool that we all know fairly well, Mimikatz. So I've downloaded that too. We'll go over here to our tools directory, and here's Mimikatz. And if I want to take these 3 files rather, we'll copy these, and then we'll go over here and paste it to our C drive. And then, oh goodness, Defender just thwarted me. So let's go ahead and click on Defender and say, hey, not scan. We want to go to our protection settings, and we want to turn off real-time protection. Yes, turn it off. And then we're going to go ahead and paste it. And there. So now we have our Mimikatz stuff because we told Defender, hey, I'm local admin, I know what I'm doing, I want this file. Okay, so we'll come back over here. And we're going to, do I have that file right here just to make it quicker? I don't. Okay, so what we're going to do is load up Mimikatz. And I do have a script that I wrote just so that I don't have to type it all out. And what it'll do is, where is that? I don't have the file on there. I'm trying to make it faster and I'm making it slower. So we got Mimikatz. Oh, I got to restore those files because I let Defender do that. Where are you here? Tools, copy from here. Oops, paste it back over here. Come on, RDP. There. All right, now I can go ahead and run it. So what this will do is it'll run the debug, it'll load the LSA dump command, and it will then dump the SAM database. So if you want to see that real quick, I can open that up too. So we've got this command right here. So it's basically just running the LSA dump for the SAM database. Right? So if you want to see that later, here's your notes. So what this does is it dumps the SAM database, and I can see in here, if I go to edit, and I can mark, I can copy this right here, which is the NTLM hash of the password of the local admin account. Now I can take this hash and I can try and crack it, right? I can run it through, I don't know, Hashcat or John the Ripper or something like that, and I can try and reverse this. But I'm trying to do really super lazy things. So let's just use our hacking tool, the internet, and go over to crackstation.net. And on this website, they have this handy little box that allows me to type in park F butt. And then it'll search their database for this hash that I'd copied off the machine. And if I typed park F butt correctly, we should see that in fact the password for this account is in their database. So not only do I not have to worry about trying to crack it, I can just ask the internet for the answer. And basically the point of this is don't use passwords that are 8 characters long because they're really super easy to undo, and they're also pretty much searchable. So don't use short passwords. Use longer machine-generated passwords and all that. But the other point is this machine has an account on it that I can get the hash and I can do other things with it. Like I know some people who have like a 25 GPU password cracking farm in their basement, right? This is not something you need to be a state-sponsored person to be able to reverse crack passwords, right? There's people local that do this kind of stuff. But what we want to do then is ask how do we stop all of this? So we'll come back over here, go back to this, and ways to stop it. Well, for one, don't have an account that you create on your own that's a local admin on the machine, right? That's a bad practice, and it usually means that you're using that account across multiple systems, right? Imaging systems tend to do that, right? You'll build a machine using Configuration Manager or something, and part of the task sequence is to create yourself this backdoor in case something goes wrong. Well, we're going to use it so that something goes wrong, and not putting it in there in the first place is a good idea. There's also LAPS, which is the Local Administrator Password Solution, so the named local administrator account. We can use group policy to roll and set that password automatically. So group policy runs a little extension that looks up its property in AD and says, hey, is this password expired? And it will regenerate a new one for you automatically. So it's just something you download from the Technic Gallery. It's free and easy to use. We can also use things like Device Guard to prevent us from running applications that aren't on a whitelist. So tools like Mimikatz are harder to invoke. And then we can use tools like Advanced Threat Analytics so that we can do some monitoring and activities of what's going on the network. So if we jump real quick over here to this web portal, I also have ATA. Advanced Threat Analytics is actually something that you deploy on-prem in Active Directory that allows you to see activities going against your domain controllers. So when I was doing those queries to say, give me a list of all of the users and all of the groups in Active Directory, ATA can see that. So right here I can say, hey, someone's doing some recon, they're trying to dump all of the users and all of the groups. That's probably not a good thing. This user generally doesn't do that sort of thing, and you'd get an alert about it. It can also see other things like pass the hash and credential replays and golden tickets and all kinds of other stuff happening against Active Directory. And with these alerts getting generated, you can start taking actions on what's happening. So that's ATA in a super brief nutshell. But if we go from here, then we're ready to move, right? We're going to do some lateral movement like an IT pro. So now that we've got this plain text password for the local admin account. Let's go back over here. Let's copy this password because, it's complex and I don't want to type it. So we'll copy that. We're going to use our hacking tool called Remote Desktop, and we're going to connect to App Server. All right. And on App Server, we want to log into App Server with the local admin account using the password we just stole and see if we can get into it. And then it tells me, hey, the cert on that machine is unknown, but I am able to log in. So this is a result of bad practice, right? Creating the local administrator account on all the machines in the domain effectively gives you this backdoor into everything in the domain. So don't do that. But we'll jump real quick back and say, what would have stopped that? How do we stop using these accounts on these machines? Well, again, laps, if we actually have accounts with different passwords on the machines, this particular tactic doesn't work. I can't log into that box. But some simple stuff like leave the firewall alone, right? If you don't allow RDP, then you can't use that method of getting into the machine. And further, we can use group policies. If you do want to have RDP enabled, do it by group policy. So many times I go into places where they are still disabling the Windows firewall because they want to RDP to or ping a machine. Like, that is the worst, laziest thing ever. Use a group policy to turn them on. And furthermore, you can lock down the allowable source IPs to do RDP. So you could use things like jump boxes, right? You can go to a jump box, and from there you can get to other things. But you can't just go from your workstation. Because remember, in this scenario, I'm sitting in the parking lot with a stolen laptop, and I just connected to a member server through RDP, right? So flat networks are a bad idea, but you can mitigate some of these with things like policies. And then network segmentation is a much better solution. It does require more work, but it means that you can control this at the network level. So if I do have access to a server, I can't just undo it. Okay, so back again here to our machine. The other part is it's time to level up. So we're on this computer, and I want to know more about what's on this machine. So other recon things I do on here, right? You can look at the roles that are installed. You can look at software installed and add remove programs. But one of the easy ones is if we go to services. Let's spell it right. Services. In the services MMC, we can see a list of services that are running, and in this case, we actually happen to be running a service under our golden needle in the haystack, right? This is what we're really looking for, right? This app service account we know it's a domain administrator, and it's being used to run a service on this machine. Now, if you think about how this works, when this computer reboots, it has to start the service up again using that service account, which means that this computer needs to know the password for the account. Turns out I'm a local admin on the machine, so I can do things as the system, including getting this password. And to do that, we're going to use another tool. So what we have over here under my tools directory is you can actually download this tool from Secure Academy. If you've heard of Paula J., she is part of this. She has this blog post about using service accounts, and there's a tool on here for getting the secrets dumper, and it's password protected, so don't worry about it. It's safe out there. But you can download the tool and extract it. I already did that, so we're just going to take the secrets dumper and we're going to take psexec, and we're going to jump over here to our server. We'll go to the C drive. We'll make ourselves a new folder called Tools, and then we'll paste our files there. Open up Command Prompt, and then we're going to go to our Tools directory. All right. So if we run, because I need to get this as a system, again, I need to run as system, which we did with psexec, right? psexec sid cmd.exe. And if I say, who am I? There we go. A little bit of delay. And I'm system again, right? So I go back to my tools directory, and I can run the CQ secrets dumper, and it tells you how to use it. It basically says, if you know the service name, we can get the value out of the registry. So what we need is the service name, right? Well, that's not difficult to get. We just double-click here. Here's our service name. We'll go ahead and copy that. Go to our tools. We'll run the CQ secrets dumper. Say the service equals the name, and then it dumps out this blob of text. So if we go ahead and click on Edit, Mark, we'll copy this blob of text right here, and then we will, oops, I missed. Right-click and copy that. We'll go to our other hacker tool called Notepad. We'll paste that. We'll go to File, Edit, where's Edit, and we'll replace all of our dots with nothing. Oops, I want to replace dot. Replace all. There. And then we'll remove our carriage returns. And then this is actually our plain text password. Right here. Right? So this is actually a pretty good password, right? It's machine generated. It's pretty long. This one would take a while to undo with a cracker, but because it's stored in the registry, I can just copy it. Right? So that's one of the bigger problems here is that I can just get this password out of here. So the question then is, well, what do we do to stop that? Right? Well, let's take a look real quick. I got another minute or so. So main thing here is the service account itself. If you can stop using what is ultimately really just a regular account that we happen to be using for services, we would not run into this problem. If you've seen Server 2012 and 2012 R2, there's something called Group Managed Service Accounts. It's an account in Active Directory that the password is not stored on these systems. Instead, it will be delegated the rights to use the credential from the machine, but it doesn't actually allow you to get the password for the account. So group managed service accounts are a much better solution than using service accounts. And again, things like device guard to stop us from using tools that we're not supposed to be running on the machines. For monitoring, we can use things like OMS, and if you haven't seen Sysmon, Sysmon actually allows you to create a whole new event log that will show you things like process forking and logging. It'll also show you network activity. Mark Rasinovich also mentioned about Swift on Security, is that Twitter account that has a configuration file for Sysmon that's actually really useful. So you can check those out as well. So let's go over to this machine. We're going to take this password. We're going to go ahead and open up our hacker tool, and we want to go to DC3, right? And on DC3, we are going to use the domain name. We're going to log in with the service account for app service, and we're going to go ahead and paste in that password and see if that lets us in. And of course it does, because now I have a domain administrator account, and I was able to RDP to the domain controller. So now that I'm on the domain controller, another pause quick. How do you stop it? Well, let's see. Right, basically what we want to do here is use things like group policy to say that if you are a service account, you shouldn't be able to log in interactively to stuff because you're supposed to be doing services. You're not supposed to be an account that people use, right? So that's a pretty good method. So as far as where we're at now, we did the recon. We're into the environment. It's time to start taking all our stuff. So let's go ahead and do that. And if we jump over to our domain controller, I wrote out a couple of scripts to make this a little bit quicker. So we're going to go ahead and edit this, copy all of our scripts, go to the domain controller, open up Notepad, paste that in here, and then we'll open up a command prompt on this box. So again, we're just using some lazy native tools on here. We're going to go ahead and make a directory. Oops, click. And this will make a directory here on the C drive for me. I'm also going to use a volume shadow copy. So volume shadow copy lets you copy files that are in use. On this machine, I have this NTDS directory, so this domain controller happens to be storing its Active Directory database on a different drive. So if we go under Windows NTDS, the file I really want is this ntds.dit file. There's also a system file that basically holds the secrets to read the contents of it, but I want those files. The problem is this domain controller is operational, so the file is locked, and just copying it's not really a good idea. So instead, we're going to use the VSS admin to create a volume shadow of the drive. So we'll go ahead, and that's what this command here does, right? So it creates a shadow copy for the C drive. We paste this in, and when you run that, it tells me, hey, I just created this volume shadow copy 3. So this might have been done before, but we'll hit 3. I'm going to do it again, and I know numerically it's going to end up being 4. So the next one is literally just a copy command, and I'm just going to copy a file off the drive, and I'm going to put it in that directory that I created. And I'm going to do the same thing on the other drive, and then I'm going to clean up my mess by deleting the shadows so that they don't linger around afterwards. So now, if I go to the C drive, go to this poem directory, I have my ntds.dit, and looks like it didn't copy my system. Well, let's do this here. Copy, paste. And I need this one here. Oh, that's why. So this is going to be 5. Come here. Copy that. Paste that. And I got 6. Forgot to delete the pound in my script. And here we go. Copy this. There we go. All right, so now I have both of the files that I need, and I can just highlight these files, send it to a little zip file, and then I've got all the stuff that I need so I can do everything with Active Directory, right? I can go and take this and crack it offline. I can get all the passwords and hashes out of people's accounts. I can see groups and all the stuff that I want in Active Directory. So I can just take this file here, copy it, go over to my USB drive again, and then I can paste it. Oops, paste it right over here, and there I just stole all of Active Directory. So that was the end goal, right? I got what I wanted. The question is, how do I stop it? Well, again, network segmentation, keep me off the DCs. That's going to be the real trick. And then using group policies, we can say things like, don't allow the service accounts to log in. If you're not a domain admin, you can't get to a DC. If you are a domain admin, you shouldn't get to anything but a DC, right? So do those kinds of permissions. And we can also restrict access to the hardware. So if this was a physical DC, that first thing I did with the sticky keys hijack, I could do that there as well. And then I maybe could use that notepad trick to copy the file off of the drive because it's not in use, right? So we've gone through the whole thing. We did our attack. We stole all the things. And if we want to look at it real quick on the mitigation list, basically the first thing that we went through here was the sticky keys hijack. And I didn't show the demo of the macro. I actually have a longer version of this that I can get you a link to if you want to watch how that part works. And then stealing the wireless network. So in doing encryption on the drive, whether that's Windows Information Protection or RMS or just BitLocker, and then using group policies to help configure the machines to make this harder to do, and monitoring with Defender ATP. The recon stage, when we were doing that, we can do things like monitoring with ATA and configurations with group policies. The domain controller exploit, we just did the stealing of the ntds.dit. There's a lot of other really cool ones I didn't show, but we can also protect a lot of that with, again, group policies and configurations on the machines. One of the things that we end up doing at Concurrency is we work with customers against the NIST CSF. And some of these at the bottom are really like the products that really align with those 5 different categories on how you do protection and improving security. So just kind of a quick slide about what we went in there. A lot of the things we covered cross over all of these different areas. And again, most of these things that I got came from other people. I didn't develop this stuff, so standing on the shoulders of giants up here. These are some of the folks that I plagiarized some of their demos and attacks from, and I really encourage you to check them out if you want to learn more. They've been big inspirations for me. And then if you want to get the deck, you go ahead and email me with Converge deck in the subject, and it'll just automatically email you back. It's not going to add you to a list. I don't share it with our marketing department or anything unless you want to be contacted. But feel free to reach out to me if you have any questions, and I hope you found it interesting. So thank you very much. Does anybody have any questions? I know we're kind of at the end and we're over, but if you do have questions, I'll take them, unless you want to come up, Daniel. No? We're all set? Okay, cool. I think Daniel's up next, right?